Hello there, and welcome to Abyssal Zenith. This is a place where curiosity sinks slowly, like sediment through dark water, settling into the quiet corners of the night where science and silence meet, where the weight of the world presses down not on our shoulders but on our imagination, where we take the hardest, darkest, most unreachable places on Earth and we pull them close, not to conquer, not to solve, just to sit with them for a while. Tonight, we are going to a place that has never truly been seen. A place that has been hidden for more than 1,000,000 years. A place so vast that it could swallow entire mountain ranges and so cold that the very concept of warmth becomes a distant memory. We are going beneath the Greenland ice sheet. Into the dark, into the pressure, into the silence, into a landscape that no human eye has ever beheld. The wind does not stop here. It does not pause or hesitate or take a breath. It moves across the ice sheet with the kind of patience that only something ancient possesses, something that has been travelling for thousands of miles over a surface so white and so flat that the horizon becomes a blur of nothing, a vanishing point that never arrives. Stand at the edge of the Greenland ice sheet, and you will feel it first on your cheeks, then in your lungs, then deep in your bones. The cold is not a temperature. It is a presence, an intelligence that knows you are not from here and does not care. The ice stretches inland for more than 1,000 miles, a frozen ocean that covers nearly 80% of the island, a cap of compacted snowfall so massive that if it melted entirely, the world's oceans would rise by 7 meters. That number has been measured and remeasured. It is precise, it is terrifying, and it is just the beginning of what we do not know. This is not a place that invites exploration. It is a place that tolerates it, barely, and only at the edges. The interior is a different world entirely, a kingdom of silence and pressure, where the ice itself moves, flowing outward from the center, under its own impossible weight, grinding against the bedrock beneath, creating a friction that scientists can measure, but cannot fully explain. The ice is not a static thing. It is alive in the way that rivers are alive, in the way that glaciers are alive, creeping forward at speeds that vary from a few meters a year near the summit to more than 50 meters a year at the margins, where the ice carves into the sea and becomes the icebergs that drift south, melting slowly, carrying with them the stories of centuries. You would not know any of this if you stood at the edge today. All you would see is the white. All you would hear is the wind. And beneath your feet, hidden by a depth of ice that could swallow entire mountain ranges, lies the question that has driven glaciologists to the edge of madness and back again. What is down there? What exists beneath the Greenland ice sheet, in the dark, in the cold, in the place where no one has ever stood and no one ever will? The answer, as far as we can piece it together, is a landscape of almost incomprehensible complexity. The bed beneath the ice is not a flat plain. It is a terrain of mountains and valleys, of lakes and rivers, of ancient rock that has not seen the sun for more than 1,000,000 years. It is a hidden continent, buried so completely that only the most sophisticated technology can map its contours. And even now, with all our satellites and all our radar and all our computational power, we have only the faintest idea of what is really down there. Here is a number that will stay with you. 81%, that is the proportion of Greenland's land area that lies beneath the ice sheet. 81% of an island, roughly 3 times the size of Texas, covered in ice so thick that in some places it exceeds 3,000 meters. 3,000 meters of ice means 3,000 meters of time, 3,000 meters of compressed snowfall, 3,000 meters of darkness and pressure, and the slow, inexorable movement of a frozen ocean. And beneath that, a surface that we have only begun to map, a surface that covers an area larger than many countries, a surface that holds secrets we are only now learning to read. The story of how we came to understand this hidden landscape is a story of technology and perseverance, of scientists who spent years in the cold, of instruments that pushed the boundaries of what physics would allow. It began, as so many scientific stories do, with a question. How thick is the ice? And that question, simple as it seems, opened a door into a world we had not known existed. The first measurements of Greenland's ice thickness came from a technique that is still in use today. Radar echo sounding. The principle is straightforward. Send a radio wave down through the ice, measure how long it takes to bounce back from the bedrock, and calculate the distance. The challenge is that you have to be above the ice to do it. And that means airplanes. That means flying over a vast, featureless, frozen desert in the middle of the Arctic. That means equipment that can survive temperatures so low that metal becomes brittle and electronics stop working. And humans must rely entirely on their machines. The early radar surveys were a triumph of determination. Pilots flew over the ice sheet at altitudes that left no room for error, sending signals into the unknown and recording the returns. They found that the ice was thick, thicker than anyone had imagined. They found that in some places, the ice sheet pressed down against rock that was itself below sea level, creating deep basins that the ice had scoured over millions of years. They found that the ice was not uniform, that it was threaded with layers and lenses and structures that spoke to a history far more complex than anyone had suspected. But those early surveys also found something else, something that would take decades to fully appreciate. They found that the bed beneath the ice was not just a surface, it was a landscape, with mountains, with valleys, with features that could only have been created by processes that had nothing to do with ice. The first maps of Greenland's bed were crude, the resolution so low that they showed only the broadest outlines. But as technology improved, as more surveys were flown, as the data accumulated, a picture began to emerge, a picture that was startling, a picture that was unsettling, a picture that suggested that the Greenland ice sheet was not sitting on a quiet, stable foundation. It was perched on a landscape of immense and violent history. Consider this: the bed beneath the ice sheet is not all rock. In some places it is sediment, soft, deformable, wet sediment that can flow, that can shift, that can change the way the ice moves above it. This sediment is the stuff of glaciers, the ground-up rock that the ice has been grinding away for millions of years. It is thick in places, thin in others, and its distribution is one of the great unknowns of Greenland science. Here is another number, 37%. That is the proportion of the Greenland ice sheet that is frozen to its bed. The rest is thawed. The ice is sliding. The ice is melting. The ice is moving in ways that we are only beginning to understand. The thermal state of the ice sheet's bed is critical. If the bed is frozen, the ice sticks to it, moving only by internal deformation, flowing like honey poured from a jar. But if the bed is thawed, if there is water at the interface between ice and rock, the ice can slide. It can move faster. It can discharge more ice into the ocean. It can contribute to sea level rise in ways that our models even now struggle to capture. And here is where the story gets truly fascinating. The thermal state of the bed is not static. It changes over time. It changes as the climate changes. It changes as the ice thickness changes. It changes as the water beneath the ice changes. The bed of the Greenland ice sheet is a dynamic system, a feedback loop, a set of interactions that we are only now beginning to explore. You are sitting here, warm and safe, listening to this voice in the dark, and somewhere beneath the ice of Greenland, water is flowing. Water that has been melted by the pressure and the warmth of the planet itself. Water that is carving channels through the rock, water that is lubricating the ice and allowing it to slide faster toward the sea. Water that we cannot see, that we cannot reach, that we can only infer from the signals that bounce back from radar and the vibrations that travel through the Earth. The tools we use to study this hidden world are extraordinary. Take the seismometers, for example. These are instruments that measure the vibrations of the Earth, the tiny movements that are caused by everything. From earthquakes, to ocean waves, to the shifting of the ice itself. Glaciologists have placed seismometers on the surface of the ice sheet, in the cold, in the wind, and they have listened to the sounds beneath. They have heard the ice creaking and groaning. They have heard the water moving. They have heard the bedrock vibrating with the stress and strain of the weight above. And what those seismometers tell us is that the bed beneath the ice sheet is not silent. It is a place of constant motion, of water and rock and ice interacting in ways that we are only now beginning to decode. There are earthquakes beneath the ice. Small ones, yes, but earthquakes nonetheless, caused by the movement of the ice and the release of stress in the rock below. There are pulses of water flowing through subglacial rivers, water that moves with such force that it shakes the ground above. There are the tiny tremors of sediment shifting and settling, the slow grinding of particles that have been trapped beneath the ice for millennia. The sound of it all, if you could hear it, would be a low and constant rumble, a bass note that never changes, a vibration that pulses through the ice and the rock and the water, a heartbeat that has been beating since before we were born and will beat long after we are gone. We have not yet talked about the lakes, the subglacial lakes. The bodies of water that exist beneath the ice sheet, some of them vast, some of them small, all of them hidden from view. These lakes are formed by the pressure of the ice above, by the heat from the earth below, by the melting that occurs at the interface between ice and rock, and they are important because they affect the way the ice moves. They affect the thermal state of the bed. They affect the way the ice sheet responds to climate change. There are hundreds of subglacial lakes in Greenland. They are deep and they are dark, and no one has ever seen them. No one has ever swum in them. No one has ever taken a sample of their water. We know they exist only because of the radar and the seismic data, the bounce of the waves, and the vibration of the earth. And that is the thing about this hidden continent. It is a place that is impossible to reach. The ice is too thick. The cold is too intense. The pressure is too crushing. We can fly over it, we can send radar into it, we can measure it from above, but we cannot go there. Not yet. Not easily. Not without technology that does not currently exist. But that has not stopped us from trying. There have been boreholes, deep holes drilled through the ice, reaching down to the bed, bringing up cores of ice and samples of sediment. The Camp Century project in the 1960s, the GSP-2 project in the 1990s, the NGRIP project in the 2000s. These were heroic efforts, years of work in the cold, dozens of scientists, millions of dollars. And they gave us our first direct samples of the world beneath the ice. What did they find? The answers are still being analyzed. The cores are still being studied. The sediment is still being dated. But we know one thing for certain. The landscape beneath the Greenland ice sheet is a place that has been exposed to the air before. It has been ice-free. It has been green. It has been home to plants and animals that no longer exist in this place. The evidence comes from the sediment, from the particles of rock and organic matter that were scraped up by the ice and trapped in the core, pollen from trees that lived more than 1 million years ago, bits of DNA from organisms that thrived in a climate that was far warmer than anything we have experienced. Material that speaks to a different Greenland, a Greenland without ice, a Greenland that was covered in forests and filled with life, and then the ice came. The ice sheet grew, and the ice sheet advanced, and the ice sheet covered everything. It buried the forests, and the lakes, and the rivers. It pressed down on the mountains and the valleys. It ground the rock to powder, and it pushed everything toward the sea. The hidden continent beneath the ice is a time capsule, a record of a world that once was, a world that could be again if the ice continues to melt. This is the story we are going to tell tonight, the story of the hidden continent, the story of what lies beneath the Greenland ice sheet and why it matters, the story of the scientists who have devoted their lives to uncovering its secrets and the barriers that have kept them from going all the way. But before we descend into the deep, into the cold, into the dark, I would love to know where you are listening from tonight. I have always been amazed by the reach of this channel, the places where these stories find their audience. Some of you are in the warmth of your homes, wrapped in blankets, the glow of the screen your only light. Some of you are in hotel rooms in unfamiliar cities, the hum of the air conditioning a small comfort against the unfamiliar quiet. Some of you are lying in the dark, in places I have never been. And I wonder what you see when you look out your window, what you feel when you hear these words. Wherever you are, I am glad you are here. This is not a story that wants to be rushed. It is a story that settles into the bones like the cold of the ice sheet, slowly, gently, but with a permanence that cannot be denied. If this journey feels like the kind of quiet curiosity you enjoy, I would be deeply grateful if you would consider subscribing to Abyssal Zenith. It helps this gentle little corner of science find more people who might need a peaceful moment too. Now, let us return to the ice. Let us return to the hidden continent and the mysteries it holds, because the story of what lies beneath Greenland is not just a story of ice and rock. It is a story of time. It is a story of climate. It is a story of a world that is changing faster than we ever imagined. The Greenland ice sheet is melting. You know this. Everyone knows this. The Arctic is warming at a rate that is alarming, that is accelerating, that is causing the ice to retreat and the sea to rise. But there is a deeper story here, a story about the interaction between the ice and the bed, about the way the ice moves and the way the water flows, about the feedback loops that are driving the ice sheet toward a tipping point that we may not be able to reverse. Consider the water. Consider the meltwater. When the sun shines on the surface of the ice sheet, when the temperatures rise above freezing, the ice melts. The water that forms is clear and cold, and it flows across the surface of the ice, finding crevasses and cracks, falling into the depths of the ice sheet, travelling down through the ice to the bed. And when it reaches the bed, it does something remarkable. It lubricates the interface between ice and rock. It reduces the friction. It makes the ice slide faster toward the sea. This is the meltwater feedback. More melting means more water. More water means faster sliding. Faster sliding means more ice discharged into the ocean. More ice discharged means more sea level rise. And more sea level rise means more melting, more water, more sliding. It is a loop, a cycle, a spiral that moves in only one direction. The glaciologists who study this process are some of the bravest people I know. They spend weeks at a time on the ice sheet, in tents that are flimsy against the wind, in instruments that are fragile against the cold. They drill holes into the ice and lower sensors into the water. They measure the pressure and the temperature and the movement. They are trying to understand the machinery beneath their feet, the hidden mechanism that controls the flow of the ice sheet, and what they are finding is that the machinery is far more complex than anyone imagined. The bed is not uniform. It is not a simple surface. It is a patchwork of rock and sediment, of frozen and thawed areas, of high friction and low friction zones. The water does not flow evenly. It channels, it pools, it bursts. It moves in ways that are unpredictable and chaotic and beautiful. The response of the ice to this water is just as complex. In some places, the ice speeds up. In others, it slows down. In some places, the water drains away quickly, reducing the lubrication and making the ice stick again. In others, the water stays. The ice continues to slide. The discharge continues to increase. The variations are enormous, and they are the subject of intense study, the focus of research that could determine the future of coastal cities around the world. And yet, despite all this research, despite all this technology, despite all this effort, the bed of the Greenland ice sheet remains largely unknown. We have mapped perhaps 10% of it at high resolution. The rest is still a blur. The rest is still a mystery. The rest is still a hidden continent waiting to be discovered. We will come back to this. We will come back to the water and the ice and the feedback loops. But first, we need to go deeper. We need to go beneath the ice. We need to understand what is really down there. The ice beneath us is not just thick. It is deep in a way that the human mind struggles to comprehend. 3,000 meters of ice is not a number you can hold in your imagination. It is not a distance you can walk or a height you can climb. It is the equivalent of 10 Eiffel Towers stacked on top of each other. It is the height of the largest mountains in the European Alps, inverted, plunging downward instead of upward, pressing against the earth, with a weight that is almost impossible to conceive. And yet, 3,000 meters is not the limit. It is not the deepest point. In some places, the ice is even thicker. The deepest borehole ever drilled into the Greenland ice sheet reached a depth of more than 3,000 meters. And it did not reach the bed everywhere. In some regions, the ice sheet is more than 3,200 meters thick. In others, it is approaching 3,500 meters. The ice is not a uniform blanket. It is a vast, flowing, sculpted landscape of frozen water, shaped by the forces of gravity and pressure and temperature over hundreds of thousands of years. Imagine, if you can, the weight of all that ice. A column of ice, with a cross-section of 1 square meter, extending from the surface to the bed, weighs approximately 3,000 tons. That is the equivalent of 20 adult blue whales stacked on top of each other, pressing down on every square meter of the bedrock beneath. The pressure at the base of the ice sheet is enormous, measured in megapascals, in atmospheres, in forces that would crush any structure built by human hands. The rock beneath the ice is compressed by this pressure. It is deformed by this pressure. It is remade by this pressure, slowly, over geological time, into something that we are only now beginning to understand. The Greenland ice sheet covers an area of approximately 1.7 million square kilometers. That is an area larger than the state of Alaska, larger than the country of Iran, larger than the entire continent of Europe, if you measure it from the Atlantic to the Urals and from the Mediterranean to the Arctic. It contains approximately 285 million cubic kilometers of ice. That is enough ice to cover the entire United States in a layer more than a kilometer thick. It is enough ice to raise global sea levels by 7.4 meters if it all melted. That number is not an estimate. It is a calculation based on decades of measurement, on satellite data and airborne surveys and ground-based observations. It is one of the most precise numbers in climate science, and it is also one of the most terrifying, but we are not here to talk about sea level rise. Not yet. Not directly. We are here to talk about what lies beneath all that ice. We are here to talk about the impossible depth, the hidden continent, the landscape that has been buried for so long that it has become something else entirely. The story of how we discovered the bed beneath the ice is a story of technological ingenuity and scientific persistence. It begins, as so many stories in polar science do, with a man named Poul Lassen. He was not a scientist, not really. He was a Danish engineer, a practical man, a man who built things with his hands. In the 1950s, Lassen was working on a project that would change the way we think about the Arctic forever. He was part of the team that designed and built the Camp Century base, a military installation buried deep inside the Greenland ice sheet. The purpose of Camp Century was not scientific. It was military. The United States, in the midst of the Cold War, wanted to test the feasibility of building nuclear missile launch sites beneath the ice. The idea was that a network of tunnels and silos, buried deep in the ice, would be invisible to Soviet satellites and invulnerable to Soviet attack. It was an audacious plan, a plan that pushed the boundaries of engineering and logistics and human endurance, and it gave us our first real glimpse of the hidden world beneath the ice. Camp Century was built between 1959 and 1960. The construction was a monumental effort. Heavy equipment was flown in from the coast. Tunnels were carved into the ice using specialized machinery. The base was powered by a nuclear reactor, the first of its kind in Greenland. The men who worked there lived in tunnels that were lit by electric lights and heated by the reactor's waste heat. They slept in bunk beds. They ate in a mess hall. They worked in workshops and laboratories and command centers. It was, for all intents and purposes, a small town buried under the ice, but Camp Century was not just a military installation. It was also a scientific research station. The Army Corps of Engineers, which managed the base, was interested in the behavior of the ice sheet. They wanted to understand how it moved, how it changed, how it responded to the weight of the tunnels and the heat of the reactor. And so they began drilling. They drilled ice cores. They drilled deeper and deeper, pulling up samples of ice that had been deposited over thousands of years. Samples that contained trapped air bubbles and dust particles and chemical signatures from ancient atmospheres. And then, in 1966, they reached the bottom. They drilled through the ice and into the sediment beneath. The drill bit hit rock. The core that came up was not ice. It was sediment. It was the first direct sample of the bed beneath the Greenland ice sheet. It was a moment of scientific triumph, a moment that opened a window into a world that had been sealed away for more than 100,000 years. The Camp Century core was analyzed by some of the brightest minds in glaciology. They found that the sediment was not just rock. It was organic. It contained traces of plants. It contained traces of life. It contained the kind of material that should not have existed beneath a kilometer of ice. Material that could only have been deposited in a world that was free of ice, a world that was warm and wet and green. The implications were staggering. If Greenland had been ice-free in the past, then the ice sheet was not permanent. It was not stable. It could come and go. It could grow and shrink. It could disappear entirely, given the right conditions. And if it disappeared, if it melted, the sea levels would rise by 7 meters, flooding coastal cities around the world, displacing hundreds of millions of people, reshaping the geography of the planet. This discovery, buried in a classified military project, was not widely known at first. It took years for the scientific community to fully appreciate its significance. But when they did, the questions started pouring in. How long had the ice sheet been there? How many times had it melted? What was the climate like when it was gone? Could it happen again? Could it happen soon? We will come back to these questions. We will come back to the sediment and the pollen and the DNA. But first, we need to understand the landscape beneath the ice. We need to understand the mountains and valleys, the lakes and rivers, the geology that lies hidden in the dark. The bed of the Greenland ice sheet is not a simple surface. It is a complex landscape, shaped by millions of years of tectonic activity and erosion and glaciation. There are mountain ranges beneath the ice. There are deep basins. There are canyons that rival the Grand Canyon in scale. There are features that have no parallel anywhere else on Earth. One of the most striking features is the Grand Canyon of Greenland. A massive canyon that extends for more than 750 kilometers from the central part of the island to the northeast coast. The canyon is more than 800 meters deep in places, and it predates the ice sheet by millions of years. It was carved by rivers, not by ice, a river system that flowed when Greenland was free of ice and green with vegetation. The canyon is still there, buried beneath the ice, a testament to a world that once was. The Grand Canyon of Greenland was discovered by accident. In 2013, Scientists were analyzing radar data from an airborne survey. They noticed a series of anomalies in the ice, features that did not seem to fit the surrounding terrain. When they processed the data more carefully, they found that the anomalies were caused by a massive canyon buried beneath the ice. The canyon was not a new discovery. It had been hidden in the radar data for years, waiting to be recognized. But once it was, it changed everything. The existence of the canyon tells us that the ice sheet is not a permanent feature of the Greenland landscape. It tells us that before the ice came, there were rivers and forests and hills and valleys. It tells us that the ice is a newcomer, a recent addition to the island's history. It tells us that the absence of ice is not a hypothetical possibility. It is a historical fact, and if the ice could disappear in the past, it can disappear again. The question is when. The question is how fast. The question is what we are going to do about it. The Grand Canyon of Greenland is not the only hidden feature beneath the ice. There are also subglacial lakes, bodies of water that exist at the interface between ice and rock, trapped beneath the immense pressure of the ice above. These lakes are rare, and they are precious. They contain water that has been isolated from the atmosphere for thousands of years, water that could hold clues to the history of the planet, water that could contain life forms that have evolved in isolation. We have explored a few of these lakes, indirectly, using radar and seismic methods. We know that they exist. We know that they are there. But we have never seen them. We have never touched them. We have never taken a sample. The technology does not exist. The funding does not exist. The political will does not exist. And that brings us to the central question of this documentary. Why scientists still refuse to go back to the Challenger Deep. Why we have not returned to the deepest point in the ocean. Why we have not explored the places that are most in need of exploration. The answer is not simple, but it is becoming clearer. The answer is not just technology. It is not just funding. It is something deeper, something more fundamental. Something that touches the very nature of exploration itself. But before we go there, we need to understand the scale of what we are trying to explore. We need to understand the depth. We need to understand the pressure. We need to understand the darkness. The Challenger Deep is the deepest known point in the ocean. It is located in the Mariana Trench in the western Pacific Ocean, approximately 11,000 meters below the surface. That is more than 11 kilometers. That is more than 36,000 feet. That is deeper than Mount Everest is tall. If you were to invert the mountain and plunge it into the sea, the pressure at the bottom of the Challenger Deep is approximately 1,086 bars. That is more than 1,000 times the atmospheric pressure at sea level. That is a weight of more than 15,000 pounds per square inch. That is enough pressure to crush any unprotected object, to compress the air out of your lungs, to flatten the bones in your body into a paste. The temperature at the bottom of the Challenger Deep is close to freezing, about 1 to 4 degrees Celsius. The water is dark. There is no light. There is no warmth. There is only the crushing weight of the water above, the immense pressure of the deepest part of the ocean. And yet, life exists there. We have found life at the bottom of the Challenger Deep. We have found organisms that thrive in the pressure, that have adapted to the cold, that have evolved to live in the complete absence of light. We have found amphipods and sea cucumbers and strange, glowing creatures that look like they come from another planet. We have found bacteria that feed on the chemicals released by hydrothermal vents. We have found the building blocks of ecosystems that operate entirely outside the boundaries of sunlight and photosynthesis. The first descent to the Challenger Deep was made in 1960. It was a historic achievement, a moment of human triumph, a demonstration of the power of technology and the courage of exploration. The bathyscaphe Trieste, piloted by Jacques Piccard and Don Walsh, descended into the deepest part of the ocean, and emerged again, having proven that it was possible to go to the deepest place on Earth and return alive. But since then, we have only returned a few times, a handful of descents, a handful of explorers, a handful of moments of contact with the deepest place on the planet. The most recent was in 2012, when film director James Cameron made a solo descent in a specially designed submersible. He was the first person to reach the Challenger deep alone. He was the first person to spend more than a few hours at the bottom. He collected samples and made observations and emerged with a new understanding of the extreme environment of the deep ocean. But even with those descents, even with the technology, even with the funding, the Challenger Deep remains largely unexplored. We have seen only a tiny fraction of its surface. We have sampled only a tiny fraction of its water. We have no idea what lies beneath the sediment, what organisms might exist in the cracks and crevices of the sea floor, what secrets might be waiting to be discovered. Why? Why have we not returned more often? Why have we not explored the deepest part of the ocean in the way that we have explored the surface of the moon? Why do we know more about the topography of Mars than we know about the topography of the Challenger Deep? The answer is not just technology. It is not just funding. It is not just the difficulty of the environment. The answer is something more subtle, something more psychological, something that touches the very nature of our relationship with the unknown. We will come back to this. We will come back to the psychology of exploration, the barriers that we impose on ourselves, the limits that we accept as inevitable. But first, we need to understand what is actually down there. We need to understand the environment of the Challenger Deep, the conditions that make it so difficult to explore, the features that make it so unique. The Mariana Trench is a subduction zone, a place where one tectonic plate is diving beneath another. The Pacific Plate is sinking beneath the Mariana Plate, creating a deep trench in the process. The trench is not just a hole in the ocean floor, it is a dynamic environment, a place of geological activity, of earthquakes and volcanic eruptions, of hydrothermal vents and chemical reactions. The sediment at the bottom of the trench is not uniform. It is a mixture of organic material and inorganic material, of sand and clay and the shells of dead organisms. It is thick in places, thin in others. It is home to a community of organisms that live in the sediment, that burrow through the mud, that feed on the organic material that falls from above. The water in the trench is not uniform. There are currents, there are temperature differences, there are variations in salinity and oxygen content. The water is not stagnant, it is moving, slowly but constantly, driven by the circulation of the ocean and the pressure of the water above. And then there are the hydrothermal vents. The vents are openings in the seafloor that release hot, mineral-rich water from the interior of the Earth. The water is heated by the geothermal energy of the planet, heated to temperatures that can exceed 400 degrees Celsius. It is rich in minerals and chemicals. It supports communities of organisms that have never seen the sun, organisms that derive their energy from chemical reactions rather than photosynthesis. The discovery of hydrothermal vents in the 1970s revolutionized our understanding of life on Earth. We had assumed that all life depended on the sun. We had assumed that photosynthesis was the only way to produce energy. But the vents showed us that there was another way. There were organisms that could survive without sunlight. There were ecosystems that were powered by the heat of the planet, by the chemistry of the Earth, by processes that operated entirely independently of the sun. This discovery raised profound questions. If life could exist in the deep ocean in the absence of sunlight, could it exist on other planets? Could there be life in the oceans of Europa, under the ice, in the dark? Could there be life on Enceladus, in the plumes of water that shoot into space? The answer was yes. The answer was perhaps. The answer was that the conditions for life were more widespread than we had ever imagined, and so we come back to the Challenger Deep. The deepest point in the ocean, a place of extreme conditions, a place of impossible depth, a place that has only been visited a handful of times. Why have we not returned? Why have we not explored it more thoroughly? Why does it remain, after all these years, one of the greatest unknowns on the planet? The answer, I believe, lies in the nature of exploration itself. Exploration is not just about going to new places. It is about the desire to go, the motivation to push beyond the boundaries of what is known, and that motivation is not always rational. It is not always driven by practical considerations. It is driven by something deeper, something that is part of the human condition. We explore because we are curious. We explore because we want to know what is out there. We explore because we are driven to understand the world around us. But that drive is not uniform. It is not constant. It waxes and wanes. It is influenced by culture and politics and economics. It is influenced by the stories we tell ourselves about the world and our place in it. The story of the Challenger Deep is a story of exploration that has been interrupted. It is a story of a place that was visited, briefly, and then abandoned. It is a story of a mystery that remains unsolved, not because the solution is impossible, but because we have chosen not to pursue it. And that choice, that decision to leave the deep ocean unexplored, is a choice that has consequences. It means that we do not fully understand the planet we live on. It means that we are missing out on discoveries that could transform our understanding of life, of the Earth, of the universe. It means that we are not taking full advantage of the opportunities that exploration provides. We will come back to these consequences. We will come back to the cost of not exploring, the price we pay for leaving the unknown unknown. But first, we need to understand something else. We need to understand the pressure. The weight of the ocean is not something you can feel from the surface. Standing on a ship, looking down at the water, you see only the shimmer of sunlight, the dance of waves, the endless blue that stretches to the horizon. But beneath that surface, beneath that placid veneer, lies a force so immense that it defies all human intuition. The water above you, if you were to descend into the deep, would press against your body with a weight that would crush you in an instant. The pressure at the bottom of the Challenger Deep is more than 1,000 times the pressure at sea level. It is enough to compress the air out of your lungs. It is enough to flatten the bones in your body into a paste. It is enough to destroy any structure that is not designed to withstand it. And yet, we have been there. We have sent submersibles into the deep. We have brought back samples and images and data. We have touched, in a way, the deepest part of the ocean. But we have not returned, not in the way that we have returned to the moon, not in the way that we have returned to the surface of Mars. The Challenger Deep remains a place of mystery, a place of secrets, a place that we have visited only a handful of times in the entire history of human exploration. What is it about the deep ocean that makes us hesitate? What is it about the pressure, the darkness, the crushing weight of the water that keeps us away? The answer is not simple. It is not just about the cost. It is not just about the difficulty. It is about something deeper, something more fundamental, something that touches the very nature of our relationship with the unknown. Here is a number that will stay with you. 95%. That is the proportion of the ocean that remains unexplored. 95% of the volume of the ocean has never been seen by human eyes. 95% of the underwater world is still a mystery. We know more about the surface of the moon than we know about the bottom of the ocean. We have mapped the topography of Mars in greater detail than we have mapped the seafloor of our own planet. We have sent robots to the surface of Venus, a planet with a temperature that can melt lead, a planet with an atmosphere so thick that the pressure would crush any human, and we have barely touched the deepest parts of our own ocean. This is not an accident. It is not a failure of technology. It is not a lack of resources. It is a choice. A collective choice, made by governments and funding agencies and scientific institutions to prioritize other things, to explore space instead of the ocean, to build telescopes instead of submersibles, to look outward instead of inward. The reasons for this choice are complex. Some of them are practical. The deep ocean is difficult to reach. The pressure is immense. The darkness is absolute. The cold is relentless. Any vehicle that descends to the Challenger Deep must withstand forces that would crush a normal submarine. The materials must be stronger than anything we have ever built. The engineering must be perfect. The margin for error is zero. The cost of such vehicles is staggering. A single submersible designed for the deepest depths can cost tens of millions of dollars. The support ships, the equipment, the personnel, the logistics, all of it adds up. A single expedition to the Challenger Deep can cost more than $100 million. That is a price that few governments are willing to pay. That is a price that few scientific institutions can afford. But there is another reason, a deeper reason, a reason that has nothing to do with money or technology. It is a reason that touches the psychology of exploration, the way we think about the unknown, the way we respond to the things that are hidden from us. We are afraid of the deep. It is a simple truth, but it is a truth that we rarely acknowledge. We are afraid of the darkness. We are afraid of the pressure. We are afraid of the creatures that might live in the depths. We are afraid of the unknown. The deep ocean is the ultimate unknown. It is a place that we cannot see, a place that we cannot touch, a place that we cannot fully imagine. And that kind of unknown is frightening. The fear is not irrational. The deep ocean is a dangerous place. The pressure is deadly. The cold is deadly. The darkness is disorienting. Any mistake, any failure, any miscalculation, and you are lost. There is no rescue. There is no recovery. The deep ocean does not forgive. And then there are the creatures, the things that live in the deep, the organisms that have evolved to survive in conditions that would kill any human. They are strange, they are alien, they are beyond our comprehension. They have teeth that are too large. They have eyes that are too big. They have bodies that are too soft and too flexible. They are the stuff of nightmares. They are the monsters that we have imagined since the beginning of human history. The things that live in the dark, the things that we fear without understanding. The anglerfish is one of the most famous deep-sea creatures. It has a glowing lure that dangles in front of its mouth, a light that attracts prey in the darkness. The light is produced by bioluminescent bacteria that live in the lure, a symbiotic relationship that benefits both the fish and the bacteria. The anglerfish is not large, not compared to the giants of the deep, but it is terrifying in its own way. It is a creature of the dark, a creature that waits, a creature that does not need to chase, because it has a light that brings the prey to it. The giant squid is another creature that haunts our imagination. It is the largest invertebrate on Earth, a creature that can grow to more than 40 feet in length, a creature that has eyes the size of dinner plates, a creature that has tentacles lined with suckers and hooks. The giant squid was once thought to be a myth, a legend invented by sailors who had seen too much and drunk too much. But it is real. It is real, and it lives in the deep, in the darkness, in the place that we cannot reach. We have found the giant squid. We have filmed it in its natural habitat. We have seen it, briefly, in the light of our submersibles. But we have not studied it. We have not understood it. We have not even begun to comprehend its life cycle, its behavior, its role in the ecosystem of the deep. And there are other creatures. Creatures that we have not even named. Creatures that we have not even seen. Creatures that live in the deepest parts of the ocean, in the cracks and crevices of the seafloor, in the sediment and the water and the darkness. We know that they exist. We have found traces of them. We have found their DNA in the water. We have found their remains in the sediment. But we have not seen them. We have not touched them. We have not studied them. The deep ocean is the last frontier on Earth. It is a place that is more unknown than the surface of Mars. It is a place that holds secrets that could change our understanding of life itself. And we have chosen, collectively, to ignore it, to leave it unvisited, to leave it unexplored. The pressure is not just the physical pressure of the water. It is the pressure of our own psychology, the pressure of our own fears, the pressure of our own limitations. We are afraid of the deep. We are afraid of the unknown. We are afraid of the things that might be down there. And so we stay away. But the pressure is also the pressure of the scientific community. The pressure to publish, the pressure to produce results, the pressure to justify the cost of exploration. Deep-sea exploration is expensive, it is difficult, it is risky, and it does not always produce results. It is not a field that rewards quick success. It is a field that requires patience, persistence, and a willingness to accept failure. The scientists who study the deep ocean are a special breed. They are patient, they are persistent, they are willing to accept failure. They are willing to spend years on a single project, years on a single question, years on a single hope. They are the people who have dedicated their lives to understanding the deep, who have spent countless hours analyzing data, who have spent countless nights on research vessels, who have spent countless days in the cold and the dark. And they are also frustrated. Frustrated by the lack of funding, frustrated by the lack of public interest, frustrated by the lack of political will. They know that the deep ocean is important. They know that it holds secrets that could change our understanding of. They know that it is worth exploring. But they cannot get the resources to do so. The funding for deep-sea exploration is a fraction of the funding for space exploration. NASA's annual budget is more than $20 billion. The annual budget for ocean exploration is less than $500 million. That is a ratio of 40 to 1. For every dollar spent on space, 40 cents are spent on the ocean, and the ocean covers 71% of the Earth's surface. The ocean is the largest habitat on the planet, and we are spending almost nothing to explore it. This is not a rational allocation of resources. It is not a reflection of the scientific importance of the ocean. It is a reflection of our collective priorities. We are more interested in space than in the ocean. We are more interested in the stars than in the abyss. We are more interested in the unknown above than the unknown below. The reasons for this are complex. Some of them are cultural. We have always looked up. The stars have always fascinated us. They have inspired us. They have challenged us. They have called us to explore. The ocean, on the other hand, has always been a barrier to travel, a barrier to trade, a barrier to communication. It is the thing that separates us, not the thing that unites us. But there is another reason, a deeper reason. A reason that is psychological and philosophical. We look up because we want to transcend our limits. We want to go beyond the Earth. We want to escape the confines of our planet. We want to reach for something that is greater than ourselves. The ocean, by contrast, is a reminder of our limits. It is a place that we cannot go. It is a place that we cannot conquer. It is a place that reminds us that we are small and fragile and mortal. The pressure of the deep ocean is a pressure that we cannot withstand. It is a pressure that reminds us of our own vulnerability. It is a pressure that reminds us that we are not masters of our own planet, and that is a truth that we do not like to confront. We have been to the Challenger Deep. We have touched the bottom of the ocean. We have proven that it is possible. But we have not returned. We have not explored. We have not understood. And the reason is not just cost. It is not just technology. It is not just difficulty. The reason is that we are afraid. We are afraid of the dark. We are afraid of the cold. We are afraid of the pressure. We are afraid of the creatures that might live there. We are afraid of the unknown, and so we stay away. We stay on the surface. We stay in the light. We stay where it is safe. But the pressure is not just the pressure of the water. It is the pressure of our own limitations. It is the pressure of our own fears. It is the pressure of our own choices. And those choices have consequences. The consequences of not exploring the deep ocean are profound. We do not understand the largest habitat on Earth. We do not understand the life that exists there. We do not understand the processes that shape the seafloor. We do not understand the role of the deep ocean in the global climate system. We are missing out on discoveries that could transform our understanding of life, of the Earth, of the universe. The deep ocean is not just a place of darkness and pressure. It is a place of life. It is a place of beauty. It is a place of wonder. It is a place that holds secrets that we have only begun to imagine, and we are choosing, collectively, to leave it unexplored. We will come back to the consequences. We will come back to the cost of not exploring, the price we pay for leaving the unknown unknown. But first, we need to understand something else. We need to understand the pressure that exists within the scientific community itself. The pressure to conform, the pressure to avoid risk, the pressure to stay within the boundaries of what is known. The scientists who study the deep ocean are not just battling the physical pressure of the water. They are battling the institutional pressure of academia. They are battling the funding pressure of grants and proposals. They are battling the social pressure of peer review and professional reputation. It is difficult to get funding for deep-sea exploration. The proposals are often rejected. The reviewers are skeptical. The funding agencies are reluctant. The scientists who propose bold projects are often told that they are too risky, too expensive, too unlikely to succeed. And so they scale back their ambitions. They propose smaller projects. They propose safer projects. They propose projects that are more likely to be funded. This is a tragedy. It is a tragedy of missed opportunities. It is a tragedy of lost potential. It is a tragedy of science that is limited by the fear of failure, the fear of rejection, the fear of the unknown. The pressure is not just external, it is also internal. The scientists who study the deep ocean are driven by curiosity. They are driven by a desire to understand, but they are also driven by a desire to succeed. They want to publish. They want to get tenure. They want to be respected by their peers. And those desires can conflict with the desire to explore. Exploration is risky. It is uncertain. It is not guaranteed to produce results. And in a system that rewards results, exploration is often penalized. The scientists who take risks are the scientists who fail. The scientists who fail are the scientists who do not get funded. The scientists who do not get funded are the scientists who do not get to explore. This is the pressure of the deep, the pressure of the water, the pressure of the institutions, the pressure of the system. It is a pressure that keeps us on the surface. It is a pressure that keeps us in the light. It is a pressure that keeps us from the unknown. But there is hope. There is always hope. There are scientists who are willing to take risks. There are scientists who are willing to fail. There are scientists who are willing to push the boundaries of what is possible. They are the ones who will take us back to the Challenger Deep. They are the ones who will explore the deep ocean. They are the ones who will discover the secrets that are hidden in the dark. The pressure will not stop them. It will not stop the curious. It will not stop the determined. It will not stop those who are driven by a desire to understand. The pressure is a challenge. It is an obstacle. It is a barrier. But it is not insurmountable. We have been to the Challenger Deep. We can go again. We can explore it more thoroughly. We can understand it more completely. We can discover the secrets that it holds. All we need is the will. All we need is the courage. All we need is the determination to overcome the pressure. The pressure of the deep ocean is a reminder of our limits. But it is also a challenge. A challenge to go beyond our limits, a challenge to push beyond what is known, a challenge to discover what is hidden. And that challenge is one that we must accept. We will come back to the pressure. We will come back to the fear. We will come back to the reasons why we stay away. But first, we need to understand something else. We need to understand the pressure that exists in the sediment at the bottom of the deep ocean, the pressure that has been building for millions of years, the pressure that is waiting to be released. The sediment at the bottom of the ocean is not just mud. It is a record of the Earth's history. It is a time capsule that contains the remains of organisms that lived millions of years ago. It is a library of information that we have only begun to read. And it is under pressure. The pressure of the water above compacts the sediment. It compresses it. It deforms it. It changes it. The sediment at the bottom of the Challenger Deep is under more than 1,000 times the pressure of the atmosphere. It is compacted into a dense, hard material that is difficult to sample, difficult to study, difficult to understand. And yet, the sediment contains secrets. It contains the remains of organisms that lived in the deep ocean, organisms that have never been seen, organisms that have never been named. It contains clues to the history of the Earth, to the history of the climate, to the history of life. It contains information that could change our understanding of the planet. The pressure of the deep ocean is not just a physical force. It is a scientific challenge. It is a challenge that we must overcome if we are to understand the deep ocean. It is a challenge that we must overcome if we are to understand the planet. It is a challenge that we must overcome if we are to understand ourselves. The pressure is not going away. It is not going to stop. It is not going to relent. It is going to keep pressing down, keep compressing, keep shaping the sediment and the rock and the water. And we must learn to work with it. We must learn to understand it. We must learn to overcome it. The pressure of the deep ocean is a reminder of the power of the planet. It is a reminder of the forces that shape our world. It is a reminder of the mysteries that still await us. And it is a call to action, a call to explore, a call to discover, a call to push beyond our limits. We have been to the Challenger Deep. We have touched the bottom of the ocean. We have proven that it is possible. And now we must go back. We must explore. We must understand. We must uncover the secrets that are hidden in the dark. The pressure is not just a barrier. It is also a challenge that we must accept, a challenge that we must overcome, a challenge that will push us to new heights of achievement. And it is a challenge that we will answer. The first time a human saw a living creature from the deepest parts of the ocean, they did not believe what they were seeing. The year was 1861. The place was the Atlantic Ocean, off the coast of Tenerife. The ship was the Electon, a French naval vessel on a routine mission. The crew spotted something in the water, something that did not belong, something that defied all their expectations of what could exist beneath the waves. The creature was enormous. It was at least 30 feet long, with tentacles that writhed and twisted in the water like serpents. It had eyes the size of dinner plates, eyes that seemed to stare directly at the men on the ship. It had a beak that could crush bone. It had a body that was soft and flexible and utterly alien. The crew of the Electon did what any rational group of men would do in such a situation. They attacked it. They harpooned it. They tried to haul it aboard. But the creature was too large, too strong, too powerful. It fought back. It thrashed in the water. It dragged the ship forward. And then, just as suddenly as it had appeared, it disappeared. It sank beneath the waves, taking with it the mystery of its existence. The crew of the Electon had encountered a giant squid. It was not the first such encounter, and it would not be the last. But it was one of the first documented encounters, one of the first times that humans had seen a creature from the deep, and it changed everything. Before that moment, the giant squid was a myth. It was a legend. It was a story that sailors told to each other in the dark. A story that was dismissed by scientists as a fantasy, a story that was not believed. But the Electon proved that the myth was real. The giant squid was real. And if the giant squid was real, what else might be out there? The giant squid is not the only creature that lives in the deep ocean. It is not even the most extraordinary. There are creatures that are more bizarre, more alien, more incomprehensible than anything that a human could imagine. There are creatures that have adapted to the pressure, the darkness, the cold, in ways that are almost impossible to understand. There is the anglerfish. The anglerfish is a creature that lives in the darkness of the deep ocean. It has a light on its head, a light that it uses to attract prey. The light is produced by bioluminescent bacteria that live in a symbiotic relationship with the fish. The bacteria provide the light, and the fish provides a home for the bacteria. It is a partnership that has evolved over millions of years, a partnership that is perfectly adapted to the darkness of the deep. The anglerfish is not large. It is only a few inches long, but it is terrifying in its own way. It has teeth that are too large for its mouth. It has eyes that are too small for its head. It has a body that is soft and flexible and utterly alien. It is a creature of the dark, a creature that waits, a creature that does not need to chase because it has a light that brings the prey to it. There is the gulper eel. The gulper eel is a creature that lives in the deep ocean. It has a mouth that is enormous, a mouth that can open wide enough to swallow prey that is larger than its own body. It has a tail that is long and thin, a tail that glows with bioluminescence, a tail that it uses to attract prey. It is a creature that is perfectly adapted to the scarcity of the deep, a creature that can take advantage of any opportunity that comes its way. There is the viperfish. The viperfish is a creature that lives in the deep ocean. It has teeth that are so large that they cannot fit inside its mouth. They protrude outward, like the teeth of a snake, giving the fish its name. It has a light on its body, a light that it uses to attract prey. It is a creature that is perfectly adapted to the darkness of the deep, a creature that is a master of ambush. There is the hatchetfish. The hatchetfish is a creature that lives in the deep ocean. It has a body that is flat and thin, like the blade of a hatchet. It has eyes that are large and sensitive, eyes that can detect the faintest traces of light. It is a creature that is perfectly adapted to the darkness of the deep. A creature that can see in a world where there is almost no light. There is the bristlemouth. The bristlemouth is a creature that lives in the deep ocean. It is small, only a few inches long, but it is one of the most numerous vertebrates on Earth. There are billions of bristlemouths in the ocean. They are everywhere. They are the most abundant fish on the planet, and almost no one has ever seen one. These are the creatures of the deep. They are strange, they are alien, they are beyond our comprehension, and they are just the beginning. There are thousands of species that we have not yet discovered. Thousands of species that we have not yet named. Thousands of species that we have not yet seen. The deep ocean is a world of life that is waiting to be discovered, a world of wonder that is waiting to be explored. The scientists who study the deep ocean are constantly discovering new species. They lower nets into the darkness, they bring up samples of water and sediment, and they find creatures that have never been seen before. It happens all the time. It happens on almost every expedition. The deep ocean is teeming with life, and we are just beginning to discover it. But the discoveries are not just about new species. They are also about new ecosystems, new relationships, new ways of living. The deep ocean is a world of symbiosis, of creatures that live together in ways that are almost impossible to believe. There are creatures that glow in the dark. There are creatures that are transparent. There are creatures that are so soft that they can be pulled through a net without being damaged. There are creatures that have no eyes because there is no light. There are creatures that have no color because there is no need for camouflage. There are creatures that are so bizarre that they look like they belong on another planet. The deep ocean is a world that is completely different from anything we know. It is a world that challenges our assumptions. It is a world that expands our understanding of life. It is a world that reminds us of how much we do not know. And yet, we have barely begun to explore it. We have visited only a tiny fraction of the deep ocean. We have discovered only a tiny fraction of the species that live there. We have only begun to understand the ecosystems, the relationships, the ways of living that exist in the dark. The pressure of the deep ocean is one of the reasons why we have not explored it more thoroughly. The pressure is immense. It is more than 1,000 times the pressure at the surface. It is enough to crush any unprotected object. It is enough to kill any unprotected human. And it is one of the greatest barriers to exploration. But the pressure is not the only barrier. There is also the darkness, the complete, absolute, total darkness of the deep ocean. There is no light below 1,000 meters. There is no sunlight. There is no moonlight. There is no starlight. There is only the darkness. The complete, absolute, total darkness that is the defining characteristic of the deep. The darkness is not just the absence of light. It is the absence of everything that we associate with light. It is the absence of vision. It is the absence of color. It is the absence of the world that we know. The deep ocean is a place that is completely, utterly, absolutely black. And that darkness is one of the reasons why we do not go there. The creatures of the deep have adapted to the darkness. They have evolved ways of living in a world without light. They have developed bioluminescence. They have developed large eyes. They have developed sensitive touch. They have developed ways of communicating that do not rely on sight. They have adapted to the darkness in ways that are almost impossible to believe. And we are just beginning to understand their adaptations. We are just beginning to understand the ways in which life has evolved to survive in the darkness. We are just beginning to understand the strategies, the relationships, the ecosystems that exist in the deep. The bioluminescence of the deep ocean is one of the most extraordinary phenomena in the natural world. The creatures that live in the deep produce their own light. They use chemical reactions to create glowing signals that they use for communication, for hunting, for defense. The light is produced by a molecule called luciferin, a molecule that reacts with oxygen to produce light. It is a reaction that is controlled by the creature, a reaction that can be turned on and off as needed. The bioluminescence of the deep ocean is a spectacle that is almost impossible to describe. It is a world of lights, of glowing signals, of flashing messages. It is a world that is alive with communication. It is a world that is full of information. And it is a world that we are only beginning to understand. The creatures of the deep ocean are not just living in the darkness. They are living in a world of light, a world of their own making, a world of bioluminescence, a world of chemical reactions, a world of communication. And we are just beginning to understand it. The deep ocean is a world of wonder. It is a world of mystery. It is a world of discovery. And it is a world that is waiting for us. It is a world that is calling to us. It is a world that is worth exploring. It is a world that is worth protecting. It is a world that is worth understanding. But we must be patient. We must be willing to wait. We must be willing to learn. We must be willing to explore. Because the deep ocean is a world that does not reveal its secrets easily. It is a world that demands respect. It is a world that demands commitment. It is a world that demands persistence. The creatures of the deep ocean have been waiting for us. They have been waiting for millions of years. They have been waiting for us to discover them. They have been waiting for us to understand them. And now, Finally, we are beginning to do so. The first human to see a living giant squid was a sailor on a ship in the 19th century. The first human to film a living giant squid was a team of scientists in the early 21st century. The first human to explore the deep ocean was a team of scientists in the mid-20th century. And the first human to understand the deep ocean will be a team of scientists in the future. We are only at the beginning. We are only at the start of the journey. We have so much to learn. We have so much to discover. We have so much to understand. And the deep ocean is waiting for us. The creatures of the deep ocean are waiting for us. They are waiting for us to explore. They are waiting for us to discover. They are waiting for us to understand. And when we do, when we finally reach them, we will find a world that is far more extraordinary than anything we have ever imagined. The deep ocean is not just a place of darkness and pressure. It is a place of life. It is a place of beauty. It is a place of wonder. It is a place that is waiting to be discovered. It is a place that is calling to us. It is a place that we must explore. We must explore it not just for ourselves, but for future generations. We must explore it not just for science, but for humanity. We must explore it not just for the sake of knowledge, but for the sake of wonder. The creatures of the deep ocean are a testament to the power of life. They are a testament to the adaptability of life. They are a testament to the resilience of life. They are a testament to the wonder of life. And they are waiting for us. They are waiting for us to discover them. They are waiting for us to understand them. They are waiting for us to appreciate them. And when we do, we will find a world that is far more extraordinary than anything we have ever imagined. The deep ocean is a world of life. It is a world of beauty. It is a world of wonder. It is a world that is waiting for us, and we must answer the call. The pressure of the deep ocean is a pressure that we must overcome. The darkness of the deep ocean is a darkness that we must penetrate. The silence of the deep ocean is a silence that we must break. And when we do, we will find a world that is far more extraordinary than anything we have ever imagined. The creatures of the deep ocean are waiting for us, and we must go to them. We will come back to the creatures of the deep. We will come back to their lives, their relationships, their ecosystems. But first, we need to understand something else. We need to understand the technology that we use to explore the deep. The submersibles, the remotely operated vehicles, the instruments that allow us to see into the darkness. And we need to understand the limits of that technology. The pressure of the deep ocean is one of the greatest challenges to exploration. The submersibles that we use to explore the deep must be strong enough to withstand the pressure. They must be made of materials that are strong enough to resist the crushing force of the water. They must be designed with precision, with a margin of error that is almost zero. The materials that we use to build deep-sea submersibles are extraordinary. They are metals and composites that have been specifically designed for the pressure. They are materials that are strong, that are lightweight, that are resistant to corrosion. They are materials that are the result of decades of research and development. The submersibles themselves are works of engineering genius. They are designed to withstand the pressure. They are designed to navigate the darkness. They are designed to operate in the silence. They are machines that are capable of exploring the most extreme environment on Earth. But even the best submersibles have their limits. They can only go so deep. They can only stay so long. They can only carry so much equipment. The pressure is a constant challenge, a constant threat, a constant reminder of the power of the deep. The remotely operated vehicles are another tool that we use to explore the deep. They are controlled by operators on the surface, operators who sit in the comfort of a ship and watch as the vehicle descends into the darkness. The vehicles are connected to the ship by a cable that carries power and data to and from the vehicle. The remotely operated vehicles have their own limits. They are limited by the length of the cable. They are limited by the power that can be delivered through the cable. They are limited by the speed of the data transmission. And they are limited by the skill of the operators. The technology that we use to explore the deep ocean is extraordinary. It is the result of decades of research and development. It is the product of some of the most brilliant minds in engineering and science. But it is not enough. It is not enough to explore the deep ocean fully. It is not enough to understand the deep ocean completely. It is not enough to discover all of the secrets that are hidden in the darkness. We need more. We need better submersibles. We need more powerful, remotely operated vehicles. We need more sensitive instruments. We need more capable robots. We need more funding. We need more commitment. We need more exploration. The deep ocean is waiting for us. The creatures of the deep are waiting for us. The secrets of the deep are waiting for us. And we must answer the call. We must explore the deep ocean. We must understand the deep ocean. We must protect the deep ocean, and we must share the wonders of the deep ocean with the world. The creatures of the deep ocean are a treasure that we must preserve. They are a treasure that we must understand. They are a treasure that we must appreciate. And they are a treasure that we must protect for future generations. The deep ocean is a world of wonder. It is a world of mystery. It is a world of discovery. And it is a world that is waiting for us. We must answer the call. We must explore. We must discover. We must understand. And we must protect. The creatures of the deep ocean are waiting for us, and we must go to them. The first machine that ever touched the bottom of the Challenger Deep was not designed for that purpose. It was not built to withstand the pressure of the deepest part of the ocean. It was not built to explore. It was built to survive, and survival in the deep ocean is the most extraordinary engineering challenge that humanity has ever faced. The year was 1960. The place was the Mariana Trench in the western Pacific Ocean. The machine was the bathyscaphe Trieste, a vessel that looked like nothing that had ever been built before. It was a sphere of steel, a sphere that was designed to withstand the pressure of more than 1,000 atmospheres. It was a sphere that was just large enough to hold 2 men, and it was a sphere that would descend into the deepest part of the ocean, into the place where no human had ever gone. The Trieste was not a submarine in the traditional sense. It was a bathyscaphe, a vessel that used the weight of water to descend and the buoyancy of air to ascend. It was a machine that was designed to be dropped into the ocean, to sink to the bottom, and to return to the surface. It was a machine that was designed to survive the pressure of the deep. The pressure at the bottom of the Challenger Deep is more than 1,000 times the pressure at sea level. It is a pressure that would crush any unprotected object. It is a pressure that would compress the air out of a human's lungs. It is a pressure that would flatten the bones in a human's body. It is a pressure that is almost impossible to imagine. And yet, the Trieste survived. It descended into the Challenger Deep. It touched the bottom. It spent 20 minutes on the seafloor, exploring the deepest point on Earth, and then it returned to the surface, bringing with it the proof that it was possible to go to the deepest part of the ocean and return alive. The Trieste was a triumph of engineering. It was a triumph of human ingenuity. It was a triumph of courage, and it was a triumph that has not been repeated as often as it should have been. Since the Trieste, only a handful of machines have reached the Challenger Deep. The Deep-Sea Challenger, piloted by James Cameron in 2012. The Limiting Factor, piloted by Victor Vescovo in 2019. A few others. A handful of descents, a handful of moments of contact with the deepest part of the ocean. And that is not enough. That is not enough to explore the deep. That is not enough to understand the deep. That is not enough to discover the secrets that are hidden in the darkness. The machines that we send into the deep ocean are extraordinary. They are works of engineering genius. They are designed to withstand the pressure. They are designed to navigate the darkness. They are designed to operate in the silence. They are machines that are capable of exploring the most extreme environment on Earth. But they are expensive. They are difficult to build. They are difficult to operate. And they are difficult to maintain. The pressure of the deep ocean is a constant challenge, a constant threat, a constant reminder of the power of the deep. The cost of building a submersible that can reach the Challenger deep is staggering. The materials alone cost millions of dollars. The design and construction cost millions more. The testing and certification cost millions more. And the operation of the submersible, the support ships, the equipment, the personnel, the logistics, all of it adds up. A single expedition to the Challenger Deep can cost more than $100 million. That is a price that few governments are willing to pay. That is a price that few scientific institutions can afford. That is a price that is a barrier to exploration, and yet the cost is not the only barrier. There is also the risk. The deep ocean is a dangerous place. The pressure is deadly. The cold is deadly. The darkness is disorienting. Any mistake, any failure, any miscalculation, and the submersible is lost. There is no rescue. There is no recovery. The deep ocean does not forgive. The risk is real. It is not a theoretical risk. It is a risk that has been demonstrated. Submersibles have been lost in the deep ocean. They have imploded. They have been crushed. They have been destroyed by the pressure of the water. And the people inside them have been lost. The loss of the submersible Alvin in 1968 is a reminder of the risks of deep-sea exploration. Alvin was a research submersible that had been used for years to explore the ocean. It was an extraordinary machine, a machine that had pushed the boundaries of what was possible. And then, in 1968, it was lost. It sank to the bottom of the ocean, and it remained there for months before it was recovered. Fortunately, no one was inside the submersible when it sank, but the loss of Alvin was a reminder of the risks of deep-sea exploration. It was a reminder that the deep ocean is a dangerous place. It was a reminder that the machines we send into the deep are not invulnerable, and yet we continue to explore. We continue to push the boundaries. We continue to send machines into the deep, because the deep ocean is a place of wonder. It is a place of mystery. It is a place of discovery, and it is a place that is waiting for us. The machines that we send into the deep are not just submersibles. They are also remotely operated vehicles. They are autonomous underwater vehicles. They are instruments that are designed to collect data. They are sensors that are designed to measure the environment. They are the tools that we use to explore the deep. The remotely operated vehicles are controlled by operators on the surface. The operators sit in the comfort of a ship, watching the video feed from the vehicle, controlling its movements with joysticks and keyboards. The vehicles are connected to the ship by a cable that carries power and data to and from the vehicle. The remotely operated vehicles have their own limits. They are limited by the length of the cable. They are limited by the power that can be delivered through the cable. They are limited by the speed of the data transmission. And they are limited by the skill of the operators. But they are also extraordinary. They can operate at depths that are impossible for humans. They can stay underwater for days. They can carry a wide range of instruments. They can explore the deep ocean in ways that are impossible for a human. The autonomous underwater vehicles are another tool that we use to explore the deep. They are not controlled by a cable. They are controlled by computers. They are programmed to follow a path, to collect data, to return to the surface. They are machines that are designed to operate independently, to explore the deep ocean without human intervention. The autonomous underwater vehicles are the future of deep-sea exploration. They are cheaper than submersibles. They are safer than submersibles. They can stay underwater for longer. They can cover more ground. They are the machines that will explore the deep ocean in the coming decades. But they are not perfect. They are limited by their programming. They are limited by their sensors. They are limited by their power. And they are limited by the complexity of the deep ocean. The deep ocean is a place of constant change. The currents are variable. The temperature is variable. The pressure is variable. The creatures are variable. The autonomous underwater vehicles must be able to adapt to these changes. They must be able to navigate in a world that is constantly changing, and that is a challenge that is just beginning to be addressed. The machines that we send into the deep ocean are extraordinary. They are the product of decades of research and development. They are the product of some of the most brilliant minds in engineering and science, but they are not enough. They are not enough to explore the deep ocean fully. They are not enough to understand the deep ocean completely. They are not enough to discover all of the secrets that are hidden in the darkness. We need more. We need better submersibles. We need more powerful remotely operated vehicles. We need more sensitive instruments. We need more capable autonomous underwater vehicles. We need more funding. We need more commitment. We need more exploration. The deep ocean is waiting for us. The creatures of the deep are waiting for us. The secrets of the deep are waiting for us. And we must answer the call. We must explore the deep ocean. We must understand the deep ocean. We must protect the deep ocean, and we must share the wonders of the deep ocean with the world. The machines that we send into the deep are a testament to human ingenuity. They are a testament to human courage. They are a testament to human determination. And they are a testament to the power of curiosity. The pressure of the deep ocean is a pressure that we must overcome. The darkness of the deep ocean is a darkness that we must penetrate. The silence of the deep ocean is a silence that we must break. And when we do, we will find a world that is far more extraordinary than anything we have ever imagined. The machines that we send into the deep are our eyes. They are our ears. They are our hands. They are the extensions of our curiosity. And they are the tools that will help us to understand the deep. But they are not enough. They cannot replace the human presence. They cannot replace the human mind. They cannot replace the human heart. The machines can collect data, but they cannot interpret it. The machines can take images, but they cannot understand them. The machines can measure the environment, but they cannot feel it. The human presence in the deep ocean is essential. It is essential because humans can adapt. Humans can make decisions in the moment. Humans can see patterns that machines cannot see. Humans can feel the wonder of the deep in a way that machines cannot. And yet, the human presence in the deep ocean is rare. It is dangerous. It is expensive. It is difficult. The pressure of the deep is a constant threat. The darkness is a constant challenge. The silence is a constant reminder of the isolation. The future of deep-sea exploration will be a combination of human and machine. The machines will do the dangerous work. They will go to the places where humans cannot go. They will collect the data. They will take the images. They will measure the environment, and the humans will interpret the data. They will understand the images. They will feel the wonder. This is the future of exploration. It is a future that is being built now by the engineers and scientists who are developing the next generation of submersibles, the next generation of remotely operated vehicles, the next generation of autonomous underwater vehicles. It is a future that is full of promise. It is a future that is full of wonder. It is a future that is full of discovery. The deep ocean is waiting for us. The creatures of the deep are waiting for us. The secrets of the deep are waiting for us. And we must answer the call. We must build the machines. We must fund the expeditions. We must train the scientists. We must explore the deep. We must understand the deep. We must protect the deep. And we must share the wonders of the deep with the world. The machines that we send into the dark are our best hope for understanding the deep ocean. They are our best hope for discovering the secrets of the deep. They are our best hope for protecting the deep. And they are our best hope for inspiring the next generation of explorers. We must continue to push the boundaries. We must continue to explore. We must continue to discover. We must continue to understand. And we must continue to protect. The deep ocean is a world of wonder. It is a world of mystery. It is a world of discovery. And it is a world that is waiting for us. We must answer the call. We must explore. We must discover. We must understand. And we must protect. The pressure of the deep ocean is a pressure that we must overcome. The darkness of the deep ocean is a darkness that we must penetrate. The silence of the deep ocean is a silence that we must break. And when we do, we will find a world that is far more extraordinary than anything we have ever imagined. The machines that we send into the deep are the instruments of our curiosity. They are the tools of our exploration. They are the vessels of our wonder, and they are the keys to unlocking the secrets of the deep. We will come back to the machines. We will come back to the technology. We will come back to the engineering. But first, we need to understand something else. We need to understand the challenges of the deep, the challenges of pressure, the challenges of darkness, the challenges of silence, and the challenges of the human mind. The deep ocean is a place that challenges us in ways that we are only beginning to understand. It challenges our engineering, it challenges our science, it challenges our courage, and it challenges our determination. But it also rewards us. It rewards us with wonder, it rewards us with discovery, it rewards us with understanding, and it rewards us with the knowledge that we are part of something larger than ourselves. The deep ocean is a place of beauty. It is a place of mystery. It is a place of discovery. And it is a place that is waiting for us. The machines that we send into the deep are our emissaries. They are our eyes and ears in the darkness. They are our hands in the silence. They are the extensions of our curiosity. And they are the tools that will help us to understand the deep. We must continue to build them. We must continue to send them. We must continue to explore. And we must continue to discover. The deep ocean is waiting for us, and we must answer the call. There is a weight that comes with not knowing. It is not the weight of the water, though that weight is immense. It is not the weight of the pressure, though that pressure is crushing. It is the weight of the questions that remain unanswered, the weight of the mysteries that remain unsolved, the weight of the secrets that remain hidden in the darkness of the deep. And that weight is heavier than any ocean. We have explored the deep ocean. We have sent machines into the darkness. We have collected samples and taken images and made measurements. We have touched, in a way, the deepest parts of the planet. But we have not understood. We have not explained. We have not answered the questions that matter most. The weight of what we do not know presses down on us, not like the pressure of the water, but like the pressure of our own limitations. What is down there? What lives in the deepest parts of the ocean? What are the creatures doing? How do they survive? How do they communicate? How do they reproduce? How do they evolve? These are the questions that we have not answered. These are the questions that keep scientists awake at night. These are the questions that drive explorers to push the boundaries of what is possible. And the questions do not stop there. What is the role of the deep ocean in the global climate system? How does the deep ocean affect the weather? How does it affect the currents? How does it affect the temperature of the planet? These are the questions that are critical to understanding the future of our world. And they are questions that we have not answered. We do not know how the deep ocean responds to climate change. We do not know how it will respond to the warming of the planet. We do not know how it will respond to the melting of the ice sheets. We do not know how it will respond to the acidification of the water. These are the questions that will determine the fate of coastal cities, the fate of ecosystems, the fate of millions of people. And they are questions that we have not answered. The weight of what we do not know is immense. It is a weight that presses down on scientists. It is a weight that presses down on policymakers. It is a weight that presses down on all of us, because the deep ocean is not a distant place. It is not a place that is separate from our lives. It is a place that is connected to everything that we do. The deep ocean is part of the planet. It is part of the system that sustains us. And we do not understand it. The deep ocean is the largest habitat on Earth. It covers more than 70% of the planet's surface. It contains more than 90% of the planet's living space. It is home to millions of species, most of which we have not discovered. It is a place of immense biodiversity, a place of immense ecological importance, a place that is critical to the functioning of the planet, and yet we treat it as if it does not matter. We dump our waste into it. We pump our carbon into it. We extract its resources without understanding the consequences. We treat it as a dumping ground, a resource to be exploited, a place that is separate from our lives. And we do not understand what we are doing. The weight of what we do not know is a weight that we carry with us every day. It is a weight that we carry in our decisions, in our policies, in our actions. It is a weight that we carry in our ignorance, in our assumptions, in our complacency. It is a weight that we carry in our failure to explore, our failure to understand, our failure to protect. We are not explorers. Not really. Not in the way that we could be. We have the technology to explore the deep ocean. We have the resources to explore the deep ocean. We have the curiosity to explore the deep ocean. But we lack the will. We lack the determination. We lack the commitment. And so the deep ocean remains a mystery that we have not solved, a mystery that we have not even begun to understand. The weight of what we do not know is a weight that we can no longer afford to carry. The deep ocean is changing. It is changing faster than we ever imagined. The temperature is rising. The acidity is increasing. The currents are shifting. The ecosystems are collapsing. And we do not understand what is happening. We do not understand why it is happening. We do not understand what it means for the future of the planet. The weight of what we do not know is a weight that we must lift. We must explore the deep ocean. We must understand the deep ocean. We must protect the deep ocean. We must answer the questions that have remained unanswered for too long. We must lift the weight of our ignorance. We must lift the weight of our complacency. We must lift the weight of our fear. The deep ocean is not a place to be feared. It is a place to be understood. It is a place to be explored. It is a place to be protected. It is a place that is full of wonder, full of mystery, full of discovery, and it is a place that is waiting for us. Waiting for us to answer the call. Waiting for us to lift the weight of what we do not know. The scientists who study the deep ocean are the ones who carry the weight of what we do not know. They are the ones who work in the dark, who collect the data, who analyze the samples, who try to understand the mysteries of the deep. They are the ones who carry the weight of our ignorance. And they are the ones who are trying to lift it. The scientists who study the deep ocean are some of the most dedicated people on the planet. They spend years in the field, months at sea, weeks in the dark. They work in the cold, in the wet, in the dangerous conditions of the deep. They are the ones who push the boundaries of what is possible. They are the ones who are trying to answer the questions that matter most. But they cannot do it alone. They need support. They need funding. They need resources. They need the commitment of governments, of institutions, of individuals. They need the will to explore. They need the determination to understand. They need the courage to protect. The weight of what we do not know is a weight that we all share. It is a weight that we must all lift. It is a weight that we can no longer afford to carry. The deep ocean is changing, the planet is changing, and we are changing with it. We cannot afford to be ignorant of the forces that are shaping our world. We cannot afford to be ignorant of the systems that sustain us. We cannot afford to be ignorant of the deep ocean. The deep ocean is not a luxury. It is a necessity. It is a necessity that we have neglected for too long. It is a necessity that we must now embrace. It is a necessity that we must explore. It is a necessity that we must understand. It is a necessity that we must protect. The weight of what we do not know is a weight that we must lift. And we must lift it together. We must lift it through exploration. We must lift it through understanding. We must lift it through protection. We must lift it through commitment. We must lift it through curiosity. The deep ocean is waiting for us. It is waiting for us to explore. It is waiting for us to understand. It is waiting for us to protect. And it is waiting for us to lift the weight of what we do not know. We can do it. We have the technology. We have the resources. We have the curiosity. We have the will. We just need to use them. We just need to commit. We just need to act. The weight of what we do not know is a weight that we can lift. And when we do, we will find a world that is far more extraordinary than anything we have ever imagined. A world of wonder. A world of mystery. A world of discovery. A world that is waiting for us. A world that is calling to us. A world that is worth exploring. A world that is worth protecting. A world that is worth understanding. The deep ocean is a place of immense importance. It is a place that is critical to the functioning of the planet. It is a place that is home to millions of species, most of which we have not discovered. It is a place that is full of wonder, full of mystery, full of discovery. And it is a place that we have neglected for too long. The weight of what we do not know is a weight that we must lift. We must explore the deep ocean. We must understand the deep ocean. We must protect the deep ocean. We must answer the questions that have remained unanswered for too long. We must lift the weight of our ignorance. We must lift the weight of our complacency. We must lift the weight of our fear. The deep ocean is not a place to be feared. It is a place to be understood. It is a place to be explored. It is a place to be protected. It is a place that is full of wonder, full of mystery, full of discovery, and it is a place that is waiting for us. It is waiting for us to answer the call. It is waiting for us to lift the weight of what we do not know. And when we do, we will find a world that is far more extraordinary than anything we have ever imagined. The deep ocean is a world of life. It is a world of beauty. It is a world of wonder. It is a world that is waiting for us, and we must answer the call. The pressure of the deep ocean is a pressure that we must overcome. The darkness of the deep ocean is a darkness that we must penetrate. The silence of the deep ocean is a silence that we must break. And the weight of what we do not know is a weight that we must lift. We must explore. We must discover. We must understand. We must protect. We must lift the weight of what we do not know. The deep ocean is waiting for us, and we must answer the call. The scientists who study the deep ocean are not the only ones who carry the weight of what we do not know. We all carry it. We all carry the weight of our ignorance. We all carry the weight of our complacency. We all carry the weight of our fear, and we all have a responsibility to lift it. The deep ocean is not a luxury. It is a necessity. It is a necessity that we have neglected for too long. It is a necessity that we must now embrace. It is a necessity that we must explore. It is a necessity that we must understand. It is a necessity that we must protect. The weight of what we do not know is a weight that we must lift, and we must lift it together. We must lift it through exploration. We must lift it through understanding. We must lift it through protection. We must lift it through commitment. We must lift it through curiosity. The deep ocean is waiting for us. It is waiting for us to explore. It is waiting for us to understand. It is waiting for us to protect. And it is waiting for us to lift the weight of what we do not know. We can do it. We have the technology. We have the resources, we have the curiosity, we have the will, we just need to use them. We just need to commit. We just need to act. The weight of what we do not know is a weight that we can lift. And when we do, we will find a world that is far more extraordinary than anything we have ever imagined. The deep ocean is a place of wonder. It is a place of mystery. It is a place of discovery. And it is a place that is waiting for us. We must answer the call. We must explore. We must discover. We must understand. We must protect. And we must lift the weight of what we do not know. The deep ocean is waiting for us. And we must answer the call. The deep ocean is not a place of endings. It is a place of beginnings. It is a place where life began, billions of years ago, in the warm, chemical-rich waters of the primordial earth. It is a place where life has continued, uninterrupted, through the ages. It is a place where life will continue, long after we are gone, in forms that we cannot imagine. And it is a place that holds the promise of discovery, of understanding, of wonder. We have not explored the deep ocean. Not really. Not in the way that we could. We have sent machines into the darkness. We have collected samples and taken images and made measurements. But we have not understood. We have not explained. We have not answered the questions that matter most. We have not fulfilled the promise of the deep. The promise of the deep is the promise of discovery. It is the promise of finding new species, new ecosystems, new ways of living. It is the promise of understanding the planet, understanding life, understanding ourselves. It is the promise of wonder, of awe, of the profound appreciation of the beauty and complexity of the natural world. The promise of the deep is the promise of knowledge. It is the promise of understanding the forces that shape our world. It is the promise of understanding the climate, the currents, the chemistry of the ocean. It is the promise of understanding the role of the deep ocean in the global system, the way it regulates temperature, the way it stores carbon, the way it sustains life. The promise of the deep is the promise of protection. It is the promise of understanding how to protect the deep ocean, how to preserve its ecosystems, how to sustain its biodiversity. It is the promise of finding solutions to the challenges that face the ocean, the challenges of pollution, of overfishing, of climate change. It is the promise of a future in which the deep ocean is not just a resource to be exploited, but a treasure to be cherished. The promise of the deep is a promise that we have not kept. We have not explored the deep ocean. We have not understood the deep ocean. We have not protected the deep ocean. We have not fulfilled the promise of the deep. And the time has come to change that. The time has come to explore the deep ocean. The time has come to understand the deep ocean. The time has come to protect the deep ocean. The time has come to fulfill the promise of the deep. We have the technology. We have the resources. We have the curiosity. We have the will. We just need to use them. We just need to commit. We just need to act. The promise of the deep is waiting for us, and we must answer the call. The deep ocean is a place of immense importance. It is a place that is critical to the functioning of the planet. It is a place that is home to millions of species, most of which we have not discovered. It is a place that is full of wonder, full of mystery, full of discovery, and it is a place that we have neglected for too long. The neglect of the deep ocean is not just a scientific failure. It is a moral failure. It is a failure of responsibility. It is a failure of stewardship. The deep ocean is part of our planet. It is part of our heritage. It is part of our future, and we have not treated it with the respect that it deserves. The neglect of the deep ocean is also a failure of imagination. It is a failure to appreciate the wonder, the mystery, the beauty of the deep. It is a failure to understand the importance of the deep to our own lives. It is a failure to recognize the promise that the deep holds. The promise of the deep is a promise that we can still fulfill. It is not too late. The deep ocean is still there. It is still full of life. It is still full of mystery. It is still full of wonder, and it is still waiting for us. We can explore the deep ocean. We can understand the deep ocean. We can protect the deep ocean. We can fulfill the promise of the deep. We just need to decide to do it. We just need to commit to do it. We just need to act. The promise of the deep is not just a promise for scientists. It is a promise for all of us. It is a promise of discovery, of understanding, of wonder. It is a promise that we can share with our children, with our grandchildren, with future generations. It is a promise that we can pass on, a promise that we can keep. The deep ocean is a place of beginnings. It is a place where life began. It is a place where life continues. It is a place where life will continue. And it is a place that holds the promise of a better future. A future in which we understand the planet, in which we protect the planet, in which we cherish the planet. The promise of the deep is a promise that we must keep. We must explore the deep ocean. We must understand the deep ocean. We must protect the deep ocean. We must fulfill the promise of the deep. We can do it. We have the technology. We have the resources. We have the curiosity. We have the will. We just need to use them. We just need to commit. We just need to act. The deep ocean is waiting for us. It is waiting for us to explore. It is waiting for us to understand. It is waiting for us to protect. And it is waiting for us to fulfill the promise of the deep. We will not be the first to explore the deep ocean. We will not be the last. But we can be the ones who make a difference. We can be the ones who understand. We can be the ones who protect. We can be the ones who fulfill the promise of the deep. The deep ocean is a place of wonder. It is a place of mystery. It is a place of discovery. And it is a place that is waiting for us. We must answer the call. We must explore. We must discover. We must understand. We must protect. We must fulfill the promise of the deep. The pressure of the deep ocean is a pressure that we must overcome. The darkness of the deep ocean is a darkness that we must penetrate. The silence of the deep ocean is a silence that we must break, and the promise of the deep is a promise that we must keep. The deep ocean is waiting for us, and we must answer the call. We have come a long way in this journey. We have explored the ice of Greenland. We have descended into the Challenger, deep. We have encountered the creatures of the abyss. We have felt the weight of what we do not know, and we have seen the promise of the deep. But the journey is not over. It is just beginning. The deep ocean is still waiting for us. It is still full of mystery. It is still full of wonder. It is still full of discovery, and it is still calling to us. The call of the deep is a call to explore. It is a call to understand. It is a call to protect. It is a call to fulfill the promise of the deep. And it is a call that we must answer. We must answer the call not just for ourselves, but for future generations. We must answer the call not just for science, but for humanity. We must answer the call not just for the sake of knowledge, but for the sake of wonder. The deep ocean is a place of immense importance. It is a place that is critical to the functioning of the planet. It is a place that is home to millions of species, most of which we have not discovered. It is a place that is full of wonder, full of mystery, full of discovery, and it is a place that is waiting for us. We must explore the deep ocean. We must understand the deep ocean. We must protect the deep ocean. We must fulfill the promise of the deep. The promise of the deep is a promise of discovery. It is a promise of understanding. It is a promise of protection. It is a promise of wonder, and it is a promise that we must keep. The deep ocean is waiting for us, and we must answer the call. We will explore the deep ocean. We will understand the deep ocean. We will protect the deep ocean. We will fulfill the promise of the deep. Because the deep ocean is part of our planet. It is part of our heritage. It is part of our future. And we must treat it with the respect that it deserves. The deep ocean is not a place of endings. It is a place of beginnings. It is a place where life began. It is a place where life continues. It is a place where life will continue. And it is a place that holds the promise of a better future. A future in which we understand the planet. a future in which we protect the planet, a future in which we cherish the planet, a future in which we fulfill the promise of the deep. That future is within our reach. We have the technology, we have the resources, we have the curiosity, we have the will. We just need to use them, we just need to commit, we just need to act. The deep ocean is waiting for us, and we must answer the call. The deep ocean is not just a place, it is a symbol. It is a symbol of the unknown, of the unexplored, of the undiscovered. It is a symbol of our curiosity, our courage, our determination. And it is a symbol of the promise that lies ahead. The promise of the deep is a promise that we must keep. We must explore the deep ocean. We must understand the deep ocean. We must protect the deep ocean. We must fulfill the promise of the deep. We will do it. We will explore. We will discover. We will understand. We will protect. We will fulfill the promise of the deep, because the deep ocean is not just a place. It is a part of us. It is a part of our planet. It is a part of our heritage. It is a part of our future, and we must treat it with the respect that it deserves. The deep ocean is waiting for us, and we must answer the call. Now, as this journey comes to a close, I want you to think about where you started. You were at the edge of the Greenland ice sheet, feeling the wind on your face, the cold in your lungs, the weight of the ice beneath your feet. You were in a place that is vast and silent and white, a place that hides a world beneath it. And now, after all that we have explored, after all that we have discovered, you are still in that place. But you are different. You have changed. You have been changed by the journey. You have been changed by the wonder. You have been changed by the mystery. You have been changed by the promise. The ice is still there. The wind is still blowing. The cold is still biting. But you see it differently now. You see the hidden continent beneath. You see the lakes and rivers, the mountains and valleys. You see the life that exists in the dark. You see the promise of discovery. And you are ready to rest. You are ready to close your eyes and let the silence wash over you. You are ready to drift, slowly, like sediment through dark water, into the peace of sleep. The deep ocean is waiting for us. But it will still be there tomorrow. It will still be there the day after. It will still be there for future generations. And when we are ready, when we have rested, when we have gathered our strength, we will return. We will return to explore. We will return to discover. We will return to understand. We will return to protect. We will return to fulfill the promise of the deep. But for now, it is time to rest. It is time to let the silence wash over you. It is time to let the darkness embrace you. It is time to let the weight of the world slip away. You are still at the edge of the Greenland ice sheet. The wind is still blowing, the cold is still biting. But you are warm. You are safe. You are home, and the deep ocean is waiting, waiting for you to return, waiting for you to explore, waiting for you to discover, waiting for you to understand, waiting for you to protect, waiting for you to fulfill the promise. But not tonight. Tonight, you rest. Tonight, you sleep. Tonight, you dream of the deep. Dream of the pressure. Dream of the darkness. Dream of the silence. Dream of the creatures that live in the abyss. Dream of the wonders that are waiting to be discovered. Dream of the promise that is waiting to be fulfilled. And when you wake, remember, the deep ocean is still there. It is still full of mystery. It is still full of wonder. It is still full of discovery. And it is still waiting for you. But for now, rest, sleep. Let the silence carry you. Let the darkness embrace you. Let the wonder fill you. This is Abyssal Zenith. Thank you for listening. Thank you for your curiosity, your patience, your courage. The ocean is vast. The deep is dark. The unknown is infinite. But we are not afraid. We are curious. And curiosity is the light that guides us through the dark ret well. Dream of the deep. Dream of the pressure. Dream of the silence. Dream of the wonder. Dream of the promise. And when you wake, remember, the deep ocean is waiting for you. But for now it is time to rest. It is time to sleep. It is time to dream. Good night.